Your P&ID says 150 psi. Your nameplate says 275 psi. Your relief valve is set at 165. 3 numbers, 1 vessel. Which one is actually the pressure? Welcome back to ASME Section 8 Division 1 in 5 minutes. Episode 2, MAWP vs Design Pressure. Let's untangle this, starting with the term that isn't even formally defined in the code, operating pressure. That's simply the pressure your process actually runs at day to day, set by your process engineer, not by Section 8. It's the starting input, not the design basis. And here's the rule that matters most. Operating pressure should never get anywhere near your vessel's real limits. Everything else in this video exists to build a safety margin above this one number. Design pressure is where the code actually speaks. UG21 says every element of the vessel must be designed for at least the most severe coincident pressure and temperature expected in normal operation, including static head. In practice, that means padding the operating pressure with a margin before you calculate a single wall thickness. A very common rule of thumb across the industry: design pressure equals operating pressure plus 10% or plus 25 psi, whichever is larger. That's not a code requirement, it's engineering practice, but it's the number that actually goes into your thickness calculations. MAWP is different, it doesn't exist until the vessel does. Per UG 98, it's the maximum pressure permitted at the top of the vessel, in its normal position, at a stated temperature, calculated from the actual thickness you built with, for every single part, and then you take the least of all those values. Why does this matter? Because plate and pipe come in standard sizes. If your calculation needs 9 mm, you probably order 10. That extra material means the finished vessel can usually handle more than the design pressure demanded. MAWP is the ceiling, calculated after the fact, stamped on the nameplate, and it's legally what your vessel is rated for. So you end up with two different numbers for a reason. Design pressure is your minimum input before construction. MAWP is your actual output after it. Because of standard plate thickness and rounding up, MAWP is almost always equal to or higher than design pressure, never lower. If your calculated MAWP ever comes out below the design pressure, that's a red flag. Something in your thickness calculation needs to be revisited before that vessel gets a nameplate. Put all three together and you get a strict order. Operating pressure stays lowest, design pressure sits above it as your engineering margin, and MAWP sits at the top as the hard ceiling. Here's the rule that actually matters on a running plant. Operating pressure must never exceed MAWP, not occasionally, not briefly, never. That's exactly why pressure relief devices exist, set at or near MAWP, to catch the vessel before it gets there. We're covering relief devices fully in episode 9, but for now, just remember the order: operating, then design, then MAWP, each one a ceiling for the one below it. Mix these up on a data sheet or a P&ID, and you are either under-designing a vessel or misreading how much margin you actually have. 3 pressures, 1 hierarchy. Operating pressure is what you actually run at. Design pressure, from UG21, is your engineering input before you build. MAWP, from UG98, is your legal ceiling after you build, and it's almost always the highest of the 3. That's episode 2. Full walkthrough with worked numbers is linked below on WeldFab World. Subscribe. Episode 3 covers impact testing and the MDMT curves.